My name is Adrian Wheatley. I'm here with Andy Wright,
Good morning, everyone.
both ergonomics and human factors consultants working with CRA ASystem. And today we're going to be talking about human factors with a focus on performance shaping factors and how they focus much of what we do when integrating human factors into systems design and safety assessments. So I'm just going to start by dispelling a few myths and banishing a few stereotypes. We're not occupational safety. We don't just do DSE assessments and conventional risk assessments, and we're certainly not human resources. That said, we do have knowledge and expertise in control room design, the application of things like ISO 11064. We do have knowledge and expertise in the domains of occupational safety and DSE risk assessments, but that's not really our focus. Our focus is on optimizing human performance, and in doing that, we share the common goal of optimizing overall system performance. So to do that, we assess systems in order to improve design, safety, and efficiency, focusing on operability, maintainability, and recovery. So ultimately, we all have our parts to play in the design of any system, and HF is all about ensuring we don't take our eyes off end user requirements. And these are the themes that will be running throughout this presentation. And do you want to just go through what we mean by system?
Yeah, thanks, Adrian. So we've obviously spoken about systems a lot during the forum, and even at the last panel, Dr. Emma Taylor was discussing systems. So the dictionary definition, to me, is a system comprises of a group of interacting entities, whatever those might be, that form a unified whole. And a system is typically influenced by things like the environment and is described by boundary, structure, and purpose. But to a human factors specialist, we like to see systems in terms of the people, the technology, and the processes that govern them, or as we like to call it, a socio-technical system.
Cool.
So I digress slightly. So what does a human factors consultant bring to the party exactly? Well, rather a lot. So in order to be a chartered ergonomist, you need to have qualifications relating to a number of core disciplines and knowledge areas. And that makes sense, right? So to understand and optimize the human in the system, we can't be content sticking to a single field of science, but really we need to draw knowledge from a diverse range of supporting disciplines, taking what we need from each of them to help us assess the human. A couple of examples, not comprehensive, but we need to have an understanding of human anatomy and physiology. We need to understand how performance may be affected by the physical working environment or job design or machine interfaces. And looking at the bigger picture, how system or organizational performance will be affected by factors such as attitudes, culture, leadership, and management. So whether we're working with engineers, with ops, or assurance, we use common methods, tools, and techniques in order to understand the context and how people relate to their environment. And at the core of what we do is task analysis, of course, but we also specialize in a range of different methods, which we'll touch upon throughout the day, but they really still aren't that comprehensive. There's so many of them, ranging from user experience and usability assessment, anthropometrics, training needs analysis, workload analysis, shift pattern assessment. The list goes on and on and on. But at the core of what we do is task analysis. There are some a subset of HF specialisms and areas to consider. So just as a final point, if anyone would like to talk to us about any of these areas, or in fact, anything we talk about today, do get in touch with us. I like to think we're quite approachable, and our contact details will be provided at the very end of the presentation. So today we're going to focus specifically on performance shaping factors. And there is a good reason for this. And it's because human performance is really at the heart of what we do. And human or system performance can vary wildly depending on the context and the situation people are faced with. But what exactly do we mean when we refer to performance shaping factors? Well, as has been touched upon a few times over the course of the forum, performance shaping factors are normally taken into account when undertaking things like human error assessment, so very sort of bread and butter stuff in nuclear. Looking at the factors, for example, that increase the probability of error. It's mainly what we look at. And we would typically apply these directly using a human reliability assessment tool, perhaps something like HART or THERP or NARA if you're in the nuclear business. And we might look at factors such as time pressure, channel capacity overload, poorly written procedures, poor HMI, that sort of thing. But if we look at the bigger picture, when human factors is just very generally supporting engineering, what becomes clear to me is that human factors specialists are always assessing performance shaping factors, namely by trying to optimize them. And although many people don't think about it this way, performance shaping factors are just as important in the design of non-safety systems and interfaces. Because even when doing something simple, like designing a phone app, if you keep getting things wrong or if you keep making mistakes as a user, even if there aren't any real safety consequences, it gets frustrating very quickly. And as we know from personal experience, I'm sure all of us do, a frustrated user is ultimately an unhappy one. And an unhappy or an unsatisfied user will quickly stop using that product and find another way, maybe another tool, maybe they'll violate the procedure or whatever sort of plans you had in mind for your user, or at worst, they'll go to a competing application or product.
Yeah, so thanks for that, Andy. I'm just going to go a little bit deeper and take a look at how human factors might typically integrate in the context of a safety-driven design project, because there may be some people out there who don't quite understand where human factors fit into this bigger picture. So in this context, HF are supporting both engineering and assurance, or the HAZAN and safety case authors. So let's look at what happens when we start assessing a hazardous system. Well, in simple terms, the greater the hazard, the more protection needs to be put in place. So this is basic risk assessment 101. And as part of that risk assessment and mitigation process, the assurance function would place safety requirements on the engineered systems. And at this phase, HF would be supporting assurance to understand the role and contribution of the human component in maintaining safety. And there's almost always a human in the loop somewhere. So where engineered safety systems can't reduce the risk or can't be relied upon to mitigate all of the risk, it will fall to the human operator. And that might be in the performance of safety actions. So where there's risk being mitigated by operator actions, it's important that the system is operable, maintainable, and recoverable. So we, human factors, will be helping engineering optimize the ergonomics of the system. We'll be focusing on performance shaping factors, things like reach, strength, lighting, temperature, tools, etc. So in the same way, the greater the hazard requires greater protection. A greater hazard imposes a greater need to optimize system ergonomics, because the operators are behaving as part of a protection system. So as you can see, all of these things and all these factors are interrelated. And by optimizing the ergonomics of the engineered design, this then feeds back to demonstrate that overall risk is reduced, placing less demand on safety systems. And it's also worth noting that even though we might be undertaking a human failures assessment to output a human error probability, it's not all about the number, but that assessment, if it's undertaken, can feed back into the design. If we undertake an assessment and we identify key performance shaping factors that negatively influence the human error probability, then there's an opportunity then for those to be addressed. And we can work with engineering and HAZAN authors at any phase of the project lifecycle. We'll come back to that later. But for more established systems, we might also be doing very similar things with facility operators as they update or revise their risk assessment. Ultimately, we're all sharing the same concerns. So let's think about this in a more practical and applied way. Andy's going to work through an exercise just to illustrate how we might intuitively think about performance shaping factors.
Thanks, Adrian. So we do love a good diagram in human factors. So now that we've been blown away with a sophisticated explanation, let's break things down in terms that I can understand. So let's imagine that you can all come with me. So let's imagine that we're all trapped in a room, dark room, with a monster. Now, of course, we can substitute the monster for any hazard, be it a machine fault, radiation, toxic substances, even your mother-in-law if you want to be creative. And first of all, you'd be thinking, well, which idiot put a monster in the room? Let's just avoid creating monsters altogether. And you would be onto something there, as this is certainly the objective of good design. Makes sense, right? But sometimes we do have to work with monsters and deal with the unavoidable problem. So what would we do? Well, firstly, I think we'd immediately start to think about detection. So can we see it, hear it, or smell it? And by doing so, we're starting to think about engineering and operational requirements. In this case, relating to things like detectability, perception, the operating environment. And so if you can detect it, then you've got a reasonable chance of stopping it, I would expect. But if you can't stop it directly, we'd want to protect ourselves from it. Or perhaps we can avoid it, perhaps even get away from it. And again, by doing so, we're discussing things like safety systems, barriers, and control systems. And failing that, you may have to fight it. And perhaps then you're wondering whether you can survive it. Now, if the monster is your mother-in-law, then you probably don't have much of a chance. But by doing so, we're talking about things like preparation, training, and recovery. And by thinking of the whole problem, we've been really quite intuitively, I'd like to think, undertaking a safety assessment, but also thinking about engineering human factors and derived requirements, or as we like to call them, end user requirements. And for those who are familiar with the lingo, you may have noticed that we've undertaken a rudimentary ERIC PD assessment.
That's right. So just for those who don't know, ERIC PD is a hierarchy of control. It's widely applied, especially amongst health and safety, other organizations. I think it came from the radiological environment. Happy to be corrected on that. But the main principles are being that you would, first and foremost, if you can, eliminate the risk. Don't have a monster in the first place, as Andy was saying. And then if you have to, you reduce the incidence or exposure to the risk, or, for example, use a substitute. And then working down the hierarchy of risk or the ERIC PD hierarchy, you think about isolating people from the source of the hazard, controlling the magnitude of the hazard and exposure to the hazard. And these are things you do as a basket of measures. You add them on. You don't just work your way down and do each in isolation. You use PPE if you have to come into contact with the hazard, or right at the very bottom, discipline, managing, implementing rules, limits, conditions, and ensuring everyone's got the right attitude and behaviors, and undertaking ongoing review of the hazard. So the ultimate aim is that solutions or safeguards should be as high up the ERIC PD hierarchy as possible.
Exactly right. We okay to move on to the next slide?
I'm seeing the next slide.
Oh, apologies, I'm not. So, assuming we're on the next slide, sorry. So,
you want to go to that one?
No, back one's fine, thanks. It's okay.
Yeah.
So, once we've understood and assessed the hazard, we can think of ways to manage it. And now our PowerPoint story has taken a rather dark twist here. But in other words, if you know what we've got, then how do we deal with it? So let's think about the other side of the problem and the potential engineering challenges as well as the opportunities. So we might consider, how do we detect the monster? So perhaps it's not easy to spot, perhaps it doesn't appear very frequently. So we may need to enhance human perception and consider how human vigilance may affect detection. Or we might need to consider human performance whilst wearing personal protective equipment, or PPE. Or perhaps human perception when operating remotely controlled systems. We might also need to consider things like speed and agility, and enhancing them through the use of machines, conditioning and training. And of course, many of us work in safety will need to consider what happens if the system fails. Now, these are just a few considerations that, again, would help us ensure that human performance and end user requirements are being considered.
That's right. So up to now, we've been thinking in terms of hazard assessment without any real consideration of the end solution. We've certainly been in the optioneering and requirements capture phase, as there might be many different ways to tackle the problem. But once the design starts to take shape or a solution is proposed, the nature of HF assessment and support will subtly change focus. And we'll go into a little more depth about HF and the project lifecycle in a minute, but we always have to accept that there'll be design compromise along the way. As we move from concept design to detailed design, we'll need to continually assess and support the designers and engineers to ensure that the end user isn't forgotten among a wash of competing design challenges. So, during that phase, we'd be poking and prodding and asking questions like, can they reach it? Is it accessible for maintenance? Can they absorb all that information? Can they tolerate the environment? Can they sustain that level of intensity? How often will they make mistakes, for example? So again, we're thinking about performance and how human performance influences the evolving design. But conversely, sometimes we also need to think about how the system might need to be protected from humans. So in my experience, especially in the design of safety systems, you obviously need to be sure that the system you design will function on demand because they're safety systems. And you might rightly undertake availability, reliability assessments, ARM, RAMs, as we heard earlier. But one of the biggest threats to the system functioning correctly might not just be the weather, wear, erosion, corrosion, radiation, but how well the operator looks after it. So you might have to consider things like, are they potentially going to hit it with something? If so, how hard and how fast? Are they likely to snap something off? How strong are they? Will they hit the end stop? If you're using a hoist, for example, that means, are they paying attention? Will they overload it? Do they know when to stop? Are they going to press the wrong buttons? Will they tamper with it? Will they maintain it correctly? So it's the simple adage, if you look after your kit will look after you. The problem being that sometimes we just don't look after the kit, mostly because it's not theirs. And brings me to, I used to work with the Army conducting Army field trials, and the equipment we gave them would often get absolutely trashed within minutes. But miraculously, their cigarettes, lighters, and mobile phones, they always stayed good and dry working condition. Anyway, back to the presentation. I made the final bullet bold because it's an example of where ergonomics goes full circle. The system won't be maintained properly if it's difficult to maintain, and that can have an effect on overall system performance, its availability and reliability, and it brings us back to basic ergonomics of accessibility, reach, usability, etc. And briefly, while we're talking about HF supporting design development, you remember at the start we talked about different skills and methods. Well, here's a few examples of typical kinds of things that HF might do, supporting engineers and assurance during design development. So we've done mobile equipment maneuverability and movement speed assessments, particularly in my current role, glove box task reach assessment, control panel ergonomics, control room layout, 2D, 3D, foam board models, full-scale mock-ups, maintenance accessibility, manual handling risk assessment. And so what I've been doing is trying to introduce the idea that HF activities might subtly change over the life cycle of a project. And this really is the art of good human factors integration. Are you on mute, Andy?
Apologies. So, sorry, let's have a closer look at how human factors fits within a typical project lifecycle. And that's because good HFI, human factors integration, does not come at the end. And this is something we'll touch upon throughout the rest of the talk, that I can't really stress enough just how important it is to consider human factors at the start of the project, because the earlier human factors is involved, the greater the benefits there will be. And anyone who has worked with human factors in the past will know that at a minimum, we'd like to see a human factors integration plan. Now, in the same way you'd expect there to be a project management plan or engineering management plan or perhaps on larger projects, you'd have an integrated engineering and assurance management plan, we'd always expect to see human factors featured and hopefully referred out to a human factors integration plan. But whatever we do, it's important that the work we do is proportionate to the size of the projects as well as the risks. And it is quite easy, and unfortunately quite common, for inexperienced human factors consultants to just assume you have to do pretty much everything. So when outsourcing your HF, if you are in that position and you do get back an integration plan that's just had the ergonomically designed kitchen sink thrown at it, you should rightly question it. As you can see on the slide, there is an awful lot of things you could do. Everything has to be proportionate.
Yeah, just to back up that point, just to say, we need to do what we do to get the job done. We really shouldn't be doing anything more or anything less.
Absolutely right. And just to give you a quick overview of the slide, it's just basically showing you what human factors integration tries to do. So it tries to make sure that human factors is integrated at the correct stages of the project to make sure that we are performing the right activities, all the way from requirements through to decommissioning. And we can undertake things such as environmental assessment or target audience description, training needs analysis, etc., etc., etc. But as you'll see in bold, everything we do is underpinned by task analysis.
Yeah, it's definitely, in my mind, the more detailed task analysis we undertake during the concept and detailed design phases becomes a really high value document or documents, because they're multi-purpose throughout the life of the project. It's always really important to have a single source of truth about how the system will function and operate, and that'll inform design development. Things like process flow diagrams, mechanical sequence diagrams, FMEA, HAZOP, CONOPS, O&M manuals, training needs analysis. So if done properly and understood, the task analysis can actually save the project time and money overall. And what I've also noticed in my experience, especially on larger projects, is that people come and go, and sometimes you have people joining the project who need to get up to speed and up the learning curve quite quickly. And it's often the early human factors documents that explain what the system is and how it works. And they're the go-to documents to help anyone understand the project, because things like the O&Ms often come way too late in the project life cycle. So the takeaway message here is that all these activities are undertaken to support engineering and assurance. We don't just do these things to satisfy our own little HF purpose in life. We have to be integrated. And fundamentally, we're a support function. We're additional resource and expertise to be used like any other. So let's just remind ourselves again what the core elements of human factors are, because these really should be shared interests among a broad variety of stakeholders. Whatever the project or program, especially larger projects, there's likely to be an expectation that human factors is properly integrated. There's several key frameworks for the integration of HFI, whether you're familiar with Manprint, and if you are, you're showing your age, apologies, DEFSTAN 00250, MILSTAN 1472, JSP 912, etc. They all have similar core elements. And these might be considered to help derive top-level end-user requirements. The three on the left specifically emphasize the human factors being brought to the system and the need to develop target audience description early in the project. I've often been challenged by project managers over the need to produce something like a target audience description, only for later in the life cycle for engineers to request a copy of it over and over again. It sets very clear guidelines as to who you're designing for, the constraints that may place on the system. Again, we're talking about performance shaping factors and human performance. The elements on the right, they reinforce the need to understand what the system needs to do to accommodate humans in support of safety. And again, the backdrop to this is the consideration of performance shaping factors. So this broadly applied framework has evolved over decades to ensure that HF is applied consistently across major projects. And admittedly, these frameworks have been driven by the need for human factors integration in the defense industry and other high hazard sectors. but they are now being applied more broadly because people understand the value of HF and, more importantly, the hazards and costs associated with not undertaking HF properly. And you don't have to think very hard to uncover many examples of where human errors contributed to significant losses: 3 Mile Island, Bhopal, Challenger, Chernobyl, Deepwater Horizon, Buncefield, Piper Alpha, Kegworth, Nimrod, recent Boeing Air 37 MAX. The point being that not addressing human factors in combination with other safety assessments can be very costly.
So hopefully there we've made a bit of a point. So the question is, so why does human factors continue to not be properly integrated in design? Why do these accidents still occur? Well, sadly, perhaps there is still a lot of ignorance out there. I think human factors is still poorly understood in many industries, and perhaps it does struggle to get to the same table as other disciplines on a project. But ultimately, one of the biggest factors that we find is no doubt cost. Now, naturally, human factor support isn't free, but you have to consider that on any engineering project that's worth its salt, you wouldn't think twice about hiring a civils expert or a CNI expert or a safety manager, project managers, etc., etc. And all are very valid and beneficial to a project. But it's still crazy, at least to me, that so many projects still don't properly consult with or fully integrate human factors, when I think we can all agree that one of the greatest variables and one of the most complex elements of the system is almost certainly going to be the humans, the people that use it. So the question is, how do we, or perhaps more appropriately, how does the industry overcome this? Well, we did monsters and people earlier, so let's now talk about things in terms of carrots and sticks. Let's start with the carrots. So, first of all, I don't believe that anybody sets out to design an inherently unsafe system. I think that's fair. I think we're all largely professional. We all have consciences and we all want to sleep at night. And all of us want to avoid a long prison sentence if possible. Then maybe that's straying a bit into stick territory there. But if you're designing a system or a service or a product, I think good human factors simply makes sense. And some of the biggest businesses on the planet, and if we take Apple, which I think is the world's biggest by value, they spend vast amounts of time and money on things like usability and user experience. Now, they know that customers don't return to bad products. No one asks them to do these assessments. But in a digital world, online reviews are merciless. There are lots of competing products, all bidding to take your market share.
Yeah, and just for a lighter moment here, when it comes to poor usability and operator error, you often hear this phrase "picnic" rolled out. I don't know if any of you heard this. Problem in chair, not in computer. But as a HF practitioner, I'd really like to challenge this notion. People really aren't that stupid. Most of them are professional. And if the computer or interface was intuitive and easy to use, there wouldn't be a problem. So I'd argue that poor end user consideration leads to operator error, but that's not a particularly sexy acronym. So we might go with poor interface causes lack of comprehension, or failed usability causes operator frustration. And for the keen-eyed amongst you, that
Thanks, Ray. Thanks for that, Adrian. That's great. I know you love your acronyms. So we've considered the carrots. We have considered the real benefits of human factors, but again, not all projects are that enlightened, or they simply don't want to fork out the capital cost of human factors. So let's look at the other side of it, the sticks. Now, sadly, for some, the regulator and the health and safety executive certainly do understand the importance of human factors. And depending on the customer or the project, most of us in our project will almost certainly need to provide evidence that human factors has been considered. Human factors is also embedded throughout regulations that most of us use on a day-to-day basis. For example, the Health and Safety at Work Act, the Manual Handling Operation regs, the Display Screen Equipment regs, Supply of Machinery regs, DEF stands, MIL standards, and of course the ONR SAPs. And now, just in case anyone from the ONR is watching, we understand the SAPs are not requirements specifically and shouldn't really be used as such, but what they do is they do set out the standards by which we are judged. Now, just to exemplify the fact that performance shaping factors are embedded in regulations, here's a quick question. So, Does anyone recognize, and feel free just to answer in your head, any of these keywords and phrases? I mean, they certainly look like human factors issues to me and performance shaping factors, but where do we think these are from? So I'll give you 3 seconds, but the simple answer is that these are all from the supply of machinery regulations, namely Schedule 2. So hopefully that just shows or demonstrates that human factors considerations are part and parcel of a lot of regulations that we know and love. Now, getting back to the sticks, so unless you're a really confident individual, you shouldn't just expect human factors to be able to come along and give your project a nice rubber stamp when it's nearing completion. Or even worse, perhaps, if you've then realized that actually there is a requirement all along to ensure human factors is integrated into the design, and you need someone to come along and kind of give it a nice tick in the box. But first of all, it is very frustrating for any human factors practitioner to be asked to substantiate the design at the very end, considering we know how beneficial our input can be at the start of a project all the way through to the end. Now, we'll of course do what we can. We're pragmatic folk, but there really is only so far we're willing to compromise, and ultimately there's only so much lipstick you can put on a pig. And of course, the other big problem is, like any design change, application of human factors that occurs late in the process is typically very expensive.
Yeah, and just to exemplify that, this slide really isn't unique to human factors. I'm sure anyone who's worked on a large project will appreciate and understand this. There's no science behind it. It just holds up. Design change becomes exponentially more expensive the later it occurs. Needless to say, as the project matures, the number of stakeholders and documents just grows and grows and grows, and a relatively simple design change that could have been made early on in the project, if we've been integrated early, can result in the need to reproduce and update lots of related documents later on in the design phase. So, as an aside, I think there's a real opportunity out there to be a lot smarter about the number of cross-reference documents produced by projects and safety cases today, because it's endlessly frustrating that the most simple of changes cost so much money, not because of the cost of the component or the service itself, but the need to update so many documents. Anyway, I've digressed, and we've come a long way. So we're just going to wrap up here and summarize. Might not have seemed like it, but this was a pretty high-level simplification of how PSFs fit into general ergonomics. Started out by saying that HF is not just about desks and chairs. We're all about optimizing operability, maintainability, and recovery. It's about optimizing system performance by focusing on end-user needs and requirements, whether they're psychological, sociological, physiological, and these are just human performance shaping factors. So good system design and ergonomics has a huge influence on human performance and the probability of human error, and the best results come when human factors is integrated correctly with engineering, assurance, and operations functions. And that means applying the right methods at the right time in the project lifecycle.
Absolutely right. And if you remember at the very start, we said that human factors is all about ensuring we don't take our eyes off end user requirements. And of course, any good presentation is all about leaving a lasting message. So to avoid anyone thinking that human factors is about feeding monsters carrots or something, we'll leave you with this slide.
Yeah, it's all about not taking your eye off the end user requirements. And HF is all about getting from top left to bottom right as quickly as possible.
Great, thank you so much. And there are the email addresses in case you'd like to contact Adrian or Andy to ask any further questions. So if you do have a question, please do put it in the chat box on the right-hand side. But I've got some have come through already, so we'll kickstart with a couple of those. So humans are fault initiators as well as fault mitigators. On balance, would it be safer if a plant didn't have human operators?
Interesting. As I said earlier, I think there's always going to be a human in the loop. I know in some industries, they really shy away from EC&I systems, for example, because of they struggle to get the reliability out of the C&I systems from a SIL 1 to 3 level. I'd argue that sometimes because of that, you can demonstrate that the human is more reliable than something electronic or mechanical. And sometimes when you're really trying to take the human out of the loop, all you're doing is shifting the problem somewhere else. So rather than the humans being in the operating loop, you're just adding the burden to the maintenance and repair loop. It's even more important that they maintain the system correctly. So I'm afraid you'll never get rid of a human in the loop anywhere.
Great, thank you. We have another question a bit on culture. So Bhushan, could you include change in working culture in terms of performance shaping factors? And the question here is thinking a little bit about the transition from operating a plant to shutting it down, as we know the AGRs are slowly coming offline.
Do you want to take this one, Andy?
Yeah, absolutely. Yeah, I think that is an important factor. Now that we move from an operations mindset to decommissioning, I think the safety culture may be influential. I think the way in which you approach decommissioning problems, obviously you are stripping away your lines of protection, and hopefully you're doing it in the right order, in the safest order possible. So, but at a high level, the big nice plaque outside of, say, EDF Energy says that safety is our overriding priority. Those kinds of cultures are still important. So perhaps in a subtle way, we're more thinking about mindset and how we approach the task, how we design tasks. But yeah, I think we need to keep safety culture always in our minds. Sometimes I think the buck does get passed up safety culture during accidents. I think there's a good reason for that. A lot of performance shaping factors at the task level normally do stem from system and organizational factors. So the short answer is yes. I think we do definitely need to keep considering culture and moving between operations and decommissioning.
Yeah, it's a notoriously difficult thing to influence as well, because cultures build up over many years, even decades, and trying to change culture, you might question, how on earth are you going to do that, because they're so embedded and ingrained. But certainly safety related and safety culture comes from the top down. It's really important that the people at the top of the hierarchy exhibit those good behaviors, and they, things like starting every meeting with a safety moment and making sure everybody's aware of safety incidents and events that happen around the site, and sharing, not blaming.
Great,
I don't know if that answered the question.
Hopefully so. I'm sure we'll hear if it didn't. So moving on to the next one. How do human factors practitioners try to understand what impact an incredibly stressful situation, such as a severe accident at a nuclear power plant, impacts human performance?
Yeah, I mean, when it comes to something like that, I've always said, when the proverbial hits the fan, all bets are off. It's really, really difficult to account for human behavior when things are going so wrong. All you can do really is prepare, and there's I'm not going to say, because it involves swear words, but PPPPP. Preventing bad performance is all about planning. You can fill in the rest of the P's. But yeah, it's all about, and even though we mentioned recoverability quite a few times during our presentation, we didn't really go into that space. But recoverability is all about thinking about what could go wrong, and how the operation, function, and operators do respond when things do go wrong. There are some predictable things that can happen if we understand what the system does in a failure mode, or to the right of the fault sequence. But really, there's only so far we can go in terms of what any individual is going to do in an extremely stressful situation.
Absolutely right. I think you move away from trying to predict human performance at a task level, and you start trying to consider the things like processes, the organizational factors, things like culture, leadership. 3 Mile Island is always a classic case of the sort of processes and procedures that were followed after the event were very muddled. The lines of communication were muddled. So that's sort of the place I would start, is try and look at the system, the social technical system, as I like to say, in a holistic way, and try and influence those higher level factors first. Because as Adrian says, when the proverbial hits the fan, people can be very unpredictable. So you have to bank on things like training, procedures, leadership, etc.
Great, thank you. And we've just got one more question before we wrap up. So in simple HRA techniques, the general underlying assumption is that more time makes operators more reliable. Is this true?
Well, a lot of HRA methods do assert that, but I don't know if they always say that makes the human more reliable. In many methods, it often says that there's more time to recover from errors, and typically you'd look at any task as being a process by which the operator may make errors, and you have to consider for each task step how those errors might be mitigated and recovered. Perhaps there's peer checking, perhaps there's an alarm. So I think it may be a simplistic statement to say that time makes you more reliable, because we know that if you have the same operator crew trying to start 3 different systems to do the same thing, we know that there is some level of dependence that won't make them any more reliable doing the task if they start the second or third system having failed the first. So I would say no, I think that is an oversimplistic statement. Simply having more time does not make you more reliable, but it certainly does give you more opportunities to recover from errors. Perhaps it does alleviate things like time pressure, of course. So if we are looking at the very narrow end where you are under pressure, then time, stress due to time pressure will apply. But if someone slaps on 10 hours and says this makes you more reliable, I think that's oversimplistic. I think there's a more nuanced explanation as to why we could make a more reliable claim on that operator.
Certainly, there's a performance distribution that goes with pressure and time pressure and stress. So at the other end of the spectrum, really bored users are just as likely to make mistakes because of the vigilance aspect of the task. And you see that with monitoring, control systems that don't really do much. And it's one of the problems that comes with extremely high system reliability. The operator or the human in the loop is just monitoring something that never goes wrong. So they've got all the time in the world. But again, when something does happen, they really need to be on it. And that's when they earn their money, because they should have been paying attention and they know what's come wrong.
Great, thank you. So I'm afraid that's all we've got time for. If we weren't able to answer your question, we'll endeavour to answer it outside of the event. There's been some great feedback in the chat about your session, so thank you so much to Adrian Wheatley and Andy Wright from Corporate Risk Associates for doing our closing session of the forum. So thank you.
Thanks, everyone.
Bye.